The Singleton pattern ensures that a class has only one instance and provides a global point of access to that instance. It is useful when exactly one object is needed to coordinate actions across the system. Here are some scenarios where using the Singleton pattern is appropriate. Single point of control. When you want a single point to control actions, such as coordinating actions in a multi-component system. For example, a configuration manager that provides access to application settings. Resource sharing. When you have a limited resource, such as a database connection or a network connection, and you want to share that resource efficiently among multiple parts of your application. Global state management. When you need a centralized point for managing global application state or settings. For instance, a logging service that collects and manages log entries from different parts of the application. Lazy initialization. When the instantiation of an object is resource-intensive, and you want to delay its creation until it is actually needed. This can help improve performance by avoiding the unnecessary creation of the object until it's necessary. Preventing multiple instantiations. When you want to prevent the creation of multiple instances of a class, ensuring that there's only one instance throughout the application. Caching. When you need a single point of control for catching frequently used data. For example, a caching mechanism where a single instance manages the cached data for the entire application. Logging. When you want to centralize logging activities and have a single point to control logging behavior. This ensures consistent logging across different parts of the application. Key component of Singleton method design pattern. Private constructor. The class should have a private constructor to prevent external instantiation of the class. Static instance. The class usually contains a private static instance of itself. Static method for instance retrieval. There is a public static method that provides access to the instance. There are various options for implementing the Singleton design pattern. Let us understand each option one by one. 1. Eager initialization. In this approach, the instance is created eagerly, i.e., at the time of class loading. In the above code, as you can see, we have created a static object of the class at the time of class loading and provided a getInstance method to access the instance of this class. Using this instance, you can call the rest of methods of the Singleton class. Eager initialization ensures that the Singleton instance is created early, but it has the drawback of potentially wasting resources if the instance is not always needed during the application's execution. If the initialization process is resource-intensive, or if the instance is rarely used, lazy initialization, creating the instance only when it is first requested, might be a more efficient alternative. Static block initialization is another approach to implement the Singleton pattern. In this method, the Singleton instance is created within a static block that is executed when the class is loaded. This allows additional logic or error handling during the creation of the instance. In this example, the instance variable is a private static field that holds the single instance of the class. It is initialized within a static block. The static block contains additional logic or error handling during the creation of the instance. In this example, a runtime exception is thrown if an error occurs during the instantiation. This approach is useful when you need to perform additional operations during the creation of the instance, or if you want to handle exceptions that may occur during initialization. Like eager initialization, static block initialization creates the instance at the time of class loading, which may lead to resource wastage if the instance is not always needed. If resource efficiency is a concern, lazy initialization, creating the instance only when it is first requested. The Bilpew Singleton, also known as the initialization on demand holder idiom, is a way to implement the Singleton pattern in Java that provides lazy initialization while maintaining thread safety. This approach leverages the fact that inner classes are not loaded until they are referenced, allowing for efficient and safe lazy initialization of the Singleton instance. In this example, the Bilpew Singleton class has a private constructor to prevent external instantiation. The actual Singleton instance is held in a private static inner class named Singleton Helper. The Singleton instance is initialized when the inner class is loaded, and since inner classes are loaded only when they are referenced, it ensures lazy initialization. The public method getInstance provides access to the Singleton instance and is the recommended way to obtain the instance. This implementation is thread-safe, and the use of a static inner class ensures that the Singleton instance is created in a lazy manner, avoiding unnecessary resource consumption. The Bill-Pew Singleton is considered a good practice for implementing thread-safe and efficient Singleton patterns in Java.